is the quiz. Any questions before I move to 7.2? Yeah? How is 7.2? Is it easy or?
Okay.
Okay. Let's see. So we'll summarize it quickly, and then we can put questions. So, trigonometric integrals. So this section is only made into two main parts, right? So this is what you need also for the exam as well, especially. So we have integration of sine power n cosine power n. Okay? Integration of tan power m secant power n. These are the two types of questions we discuss in this section. Okay? So any integration on this form, you use these techniques. Okay? Alright, so what do we need here? Like, how do we solve this? So we have a couple of cases to discuss. Now, I'm going to discuss the sine first. I'm going to ignore this now. I'm going to discuss the sine and cosine. Sine times cosine. Just to note, it's either sine times cosine or tan times secant. Any other combination can be reduced by trigonometry. Like if I have sine multiplied by tan. There is no case for this. So what you have to do is you have to reduce everything in its basic definition. What's the basic definition of tan? Sine over cosine. And then this is sine x, right? And then what do? You combine it, becomes sine squared over cosine. You know, something like this, okay? So any other combination can be simplified by trigonometric relations, okay? So you only should end up with any of these two cases, nothing more, okay? All right, let's say you ended up with this, okay? So in a question in sine and cosine, we have two main cases. Case one, either
both could be
n or m is odd. It could be both, but either one of them is odd, right? Okay, what do I do? Take one piece number odd. Okay, and then reduce the rest using sine squared plus cosine squared equal 1. And then use the substitution u equal the function you didn't use. Now I know this might sound a little weird, but let's have an example and see how we can apply these exactly. Okay, this works in any exam. Okay. So let's say I have integration of sine power 5x and then cosine power 3x. Let's say 4. Now, can you see an odd power?
Yes.
You know what odd numbers are, right?
Yes.
Okay. Okay, I can see an odd power. Perfect. Do I care about the other one? Is there a restriction on it? Okay, if this is odd, does this mean that this should be even?
No.
Does this mean that this should be odd?
No.
This could be anything. Positive, negative, integer, fraction, 0. That's fine. Anything. As long as you have an odd, you can apply all of this. Okay? Clear? Okay, so I can make I can go crazy. I can do negative 7 over 2. I don't care. Okay? It doesn't matter. So don't get scared by a question. As long as you see a product, one of them is odd, it's this case. Okay. So we're gonna apply the steps. Take one piece from the odd. What does that mean? Take one piece from the 5, it becomes 4.
Right.
Sine 4, sine x, cosine negative 7 over 2 x. Reduce the rest. The rest of what? The rest of this guy.
Yes.
Of this guy. So what's the meaning? Sine power 4. 1 minus cosine squared, you said?
Yeah, but for now, sine squared.
Yeah, it's sine squared all power 2. So it becomes 1 minus cosine squared all power 2. This is what I mean by reduce the rest. So this is step 1 and this is step 2. And then I'm going to rewrite the rest of the question. Now we'll make a substitution. U equals cosine H, because it's the one I didn't use. I never used cosine in all the steps, right?
Yes.
So now I can make a substitution and say U equal cosine. And you can see the function and its derivative is exactly here. Sine x dx. I mean, minus doesn't matter that much. Okay? And then I can carry on with the solution. After that, it's a substitution problem, so you can just do algebra here. So, okay. So it becomes what? Sine x dx, I replace it with minus du, right?
Yes.
The minus, I'll put it outside. Okay. This is u, this is u. So 1 minus u squared, u negative 7 over 2. After this, it's basically an algebraic expansion. Just expand and it becomes power rule. How do I expand this? Do you remember? A minus b squared is a squared minus 2ab plus b squared. 1 minus 2u squared plus u power 4. All times u negative 7 over 2. Distribute this. U negative 7 over 2 minus 2u. 2 minus 7 over 2 is how much? Negative 3 over 2. Plus u power 4 minus 7 over 2 is half. This integration is very basic. Power rule here. Yeah? So minus u negative 5 over 2 over negative 5 over 2. If you add 1, the same thing. You add 1 here. And the same thing you add 1. And then plus c, right?
Yes.
And then, can I stop here?
No.
No, it's a
You
substitution.
need to bring
He gave
back
me in
the
x, I should
cosine.
answer in x. Right? So, I just do one more step and put everything back to x.
We remove the plus c, right?
Why?
No. So we can substitute back and then plus c.
Yeah, sure, it's fine. If you put it here, it doesn't,
Okay.
it's the same meaning. Okay, it's fine. So minus, this becomes negative 2 over 5. Then this is u as cosine, negative 5 over 2. And then minus is plus, 2 goes up, so it becomes 4 cosine x over half plus 2 over 3 cosine x 3 over 2 all plus c. Good?
Yes.
Any questions? Let me take one from the homework. I've seen a good one. Do you have it open? The sine cube. Yeah. The sine cube something. No, sine cube of root x, right? Over root x. Okay? Alright, so how do we do something like this? Again, like by parts, you always have to have substitution back in your head, just in case. Because I can see a function as derivative, right?
Yes.
Root x, the derivative of root x contains root x, right? So if u equals root x, then du is 1 over 2 root x. I don't have the 2, it's fine. Like 1 over root x dx, I have that, equal 2 du. So this and this will be replaced by 2 du. I'll put the 2 outside. And then sine cube of u. Now, which case is this?
Odd.
The odd. Do I have to have a cosine?
No.
It's 0, right? I told you, if one of them is odd, the other one could be anything.
Yes.
Now, in this case, this is power 0,
Yes.
which is 1, so it's fine, right? As long as you have one odd, that's completely fine. Okay, we're gonna apply the same exact procedure. Take one piece of the odd, and reduce the rest of that odd using the trigonometric rules. So u equals now,
The one that we didn't touch.
which is sine, which is cosine, right? Cosine, which is cosine. So u equal cosine u. Let me use another variable for the substitution. T equals cosine u. Dt equal minus sine u du. I have sine u, du. This and this will be replaced with minus dt. So that's dt. And then I have 1 minus t squared. Basic integration now. Alright? So you have negative 2, t minus t cubed over 3, which is negative 2. What's t? Cosine u.
Cosine.
Cosine cube u over 3. I need to put the u back.
Yes.
Remember, u is root x. So negative 2 cosine root x minus cosine cube root x over 3 plus c. I'm done. Okay?
Yes.
Any questions, guys? Anything? Okay. We can go now to the other case of sine and cosine, where these two both, whoever is whispering, you whisper very loudly. I don't mind talking, by the way, but you actually talk very loudly, even if you whisper. Both are even. Okay? Both powers are even. Okay? So that's the other case. So what do we need to use? This is unrelated to the method thinking. The method here are unrelated to the method here. Here, you need to use two things, strictly, nothing else. Cosine square equal half 1 plus cosine 2x. It's a trig identity. I think I wrote it last time, I'm not sure. And this 1 minus cosine 2x. Good? So these are the two identities that you need to know. Only for this case, nothing else. So in that case, I only use
Professor, if sine was even and cosine was odd,
in this case.
صح, okay. Okay,
See?
صح.
So I'm trying to make it
Yeah.
more general,
Yeah.
and I want you to memorize less.
Yeah.
All right? I want you to understand more. So it's this case. There's nothing else you can do. It's only these two cases. You will never see anything else. Type. Both are even, by the way. 0 is counted as an even number.
Yes.
Yeah, in this context. So for example, I could have sine power 4 and cosine power 0, which is not there, it's 1. So sine power 4 can still be solved like this.
Yeah.
Alright, so this is also counted. So 0 is even in this case. Power 0 is even. Alright, so let's take a question. Let's say sine squared of 3x So the procedure is, you just apply these two formulas. Whenever you see them, apply them. Okay? So I see a cosine square, I'm going to replace it with half. Half. 1 minus cosine. What? 1 minus cosine what? 2x.
This is going to be 2 times 3x.
2 times 3x, so 6x. Don't do 2x, it's a common mistake, yeah? And then times half 1 plus cosine 6x, yeah? So here it's a little of simplification here. So I'm gonna take the half times half, which is 1 over 4 outside of the integration. I'm gonna now distribute, it becomes like this, 1 minus cosine times 1 plus cosine, right?
Yes.
You can do FOIL. Yeah?
Yes.
You can simplify it. So what do you have? 1 times 1 is 1. Minus cosine. And then there is plus cosine times 1. They cancel each other. It's like a minus b times a plus b. A squared minus b squared. So you get 1 minus cosine squared of 6x. What's 1 minus cosine squared? Cosine squared, right? Okay, so 1 over 4, integration sine squared of 6x dx. How do I do this? Which case is this?
Even.
Both are even. This case is both are even, right?
Same case.
This one.
Yeah. 1 over 2.
Yeah. Sine is there, cosine is not there. That's fine, but it's even. Both are even. Does that make sense?
Yes.
So again, same thing. Half 1 minus cosine of
2x.
12x.
12x.
2x, true, Habib.
12, my bad.
So, integration, sorry. Integration. Okay? Yeah. 1 over 2 times 1 over 4 is 1 over 8. Integrate 1, that's x. Integrate cosine is sine 12x.
Over
You have to
12.
divide by 12 plus. That's the answer. Any question? So if I want to integrate cosine power 4, I do this. Cosine power 6, I do this. Cosine power 10 times cosine power 20, I do this. Okay? Alright. Let's do tan and secant. So So again, I have two cases here. Okay. Case 1. Power of tan is odd. If power of tan is odd, do I care about secant? No.
No.
Okay? Fine. What are the steps?
one piece.
No?
Take one piece from the hood.
No, no. It's not like that.
Okay.
It's not like that. So you need to pull, I believe you need to pull a secant x tan x out.
Oh, yes, yeah.
Basically,
Huh?
if it was like tan free, you take 1 second of tan.
No, no, you don't do that. We don't discuss these questions. Okay? And then reduce.
You can put a tan out and then use the
Yeah.
secant square.
Tan squared plus 1 equals secant squared, yeah?
Yeah.
Yeah. Use tan squared plus 1 equals secant squared. And then what's the substitution?
U equals tan x.
Secant x.
Secant.
But sometimes it can be tan x, right?
No, that's the other case.
No, even when tan is old.
Really? Who said this?
There's an example.
Show me.
I didn't finish it, but you did it.
Mm.
Yeah, because it's not cube. Yeah, because it's not cube. These are like case by case questions. But I'm talking when I have both secant and tan here. Both secant and tan are available, yeah? Good? Why do I make u equal secant? Because the derivative of u is secant tan. That's why I pull it out. Okay? We pull out the derivative. We pull out du. Even here, if you notice. We pull out du. The one we didn't use is the u. So the du is the one we pulled, right? Okay, so let's take an example. Example, let's say tan cube x, secant cube x. Okay, so let's pull a tan and secant out, yeah? Let's pull a tan and secant. So tan, it becomes tan square, secant square, secant x, tan x. And then I'm going to reduce the rest of tan to 1 minus, sorry, to secant square minus 1, yeah?
Yeah.
Yeah. Finally, u equals secant. So the u is
Secant x tan x.
okay. So what do you get? You get u squared minus 1 u squared du, right?
Yes.
This is du. Exactly. Alright, so you have u power 4 minus u squared du, which is u5 over 5 minus u cubed over 3 plus c, and then you have what's u? Secant.
Secant.
Okay, that's answer. Any questions here? Okay. Case 2.
How many cases are in tan secant?
Actually, there's 3, I would say. Because tan and secant are not nice like sine and cosine. Yeah, so the third case you have is like the special cases. For example, integration of secant alone, secant cube, secant power 4, secant power 5, 7, these things. These are special cases. Like the one she said also, tan cube as well, tan power 5, the same thing. Right?
Yeah, when tan is odd.
When tan is odd and secant is not there.
Yeah.
Secant is not there. So the procedure gets different. Here, we have to have a secant. You must have a secant. You must have at least one secant. Okay. But here power of secant x is even. So what do? You pull secant squared x out, Okay? And use, again, tan squared plus 1 equals secant squared to simplify the rest. And then u equal, this is du. So what's u? It's tan. Okay? It's tan. Okay. So let's do a question on that one. Let's do something like this. Something like this. Okay? I don't care what tan is. Okay? Yeah. Yeah, we don't care what tan is. It's fine. Okay? So, but again, you have to have a tan. Okay? So tan negative half x. I pull a secant square out. And then this is what I pulled out. I need to replace this with the identity. The remaining. So secant squared x. What's secant squared? Tan squared plus 1. And u equals? Du equals? Secant squared x. So it becomes u negative half. And then this is du, right? This is du. And then this is u squared plus 1. Now it becomes a basic integration. 2 minus half is 3 over 2. Okay. And then what do I have? Just power rule. Just power rule.
You don't integrate?
No, power rule, yeah.
Oh.
Integration using power rule. U 5 over 2 over 5 over 2 plus u half over half c, which becomes 2 over 5. What's u? Tan. This is 2 tan x over half. Clear? Now, more cases on secant tan. More cases on like special cases. The first one is integration of secant alone, power 1. Okay? Which is what? This is did he give you this? It's len secant
And
x.
secant x plus.
This one memorize it. You don't have to show how you got this. Okay. And secant cube. Did you do this in class? Don't think you did. But there is secant cube. You cannot solve this by regular methods. You can do it by parts. Yeah. Okay. I know it's not clear, but it's like that's why it's a special case. Okay. You can do this by parts if you say secant squared x times secant x. And then what do? You do u equal something easy to integrate here is secant squared because it becomes tan. right? And something easy to differentiate is secant. Becomes secant x tan x. Yeah? And then what happens? So you get secant tan minus integration secant tan squared. But tan squared is what? What's tan squared? Secant squared minus 1. Yeah? So it becomes secant cube minus secant. Oh, I ended up with the same question. You see? What's this originally? What's the question? Secant cube. So I have the question here and here. Yeah? I'm gonna split the integrations. I'm gonna put an integration here. Okay? So I can move this, because this is my unknown. I can move these together on one side. So I'm gonna get 2 times the integration of secant cube equal secant tan minus integration of secant, we have it, then secant x plus tan x. And then what do you do finally? To solve for this, divide by 2. This is called the loop integration, if you heard about it. I think he explained it in class. No? When you get the question and the same question in the middle of the solving,
He did mention it.
but did he solve something on it?
I'm not sure.
Especially, it comes in by parts. When you have, let's say, e to the x times cosine x, something like this. He never mentioned it? Okay. We'll talk about it next time, it's fine. It's a special case on by parts as well. Okay. No problem. Yes. Okay, this is how we do something like this.
So this 2 goes down, right?
Yeah. So this is a case-by-case question. So you don't need, yani, if they ask you something like this in the exam, you do exactly what I did. It's a case-by-case question. For the secant alone, you can just answer without showing any steps. It's fine. So yep, let me take this and then we can do. Ayman.